Okay, Professor, this is the last video demonstrating the symbolic analysis. And let me share my screen first. Then in this case, I have the part 4 Python code here. So let's start from the beginning. I have to import all the library that we need in this program. Then as well, I'm going to print out all the values of the parameters, including the inductor, capacitor, and a resistor. And the requirement uh, all for all these analysis is at least 3 loops for the RCL circuits. I could show like I will have definitely more than 3 loops in the part 2, the AC and transient analysis, and so in according to I have two parallel uh two parallel resistor and two parallel inductor. So I believe I will have 4 loops in the part 3. So in this case, I since I have 2 resistor in parallel and 2 inductor in parallel, so I have exactly uh 3 loops. And so I connect the voltage source to the N1 node and to the ground with the AC values equal to 1 and the DC values equal to 1. Then I have to check the output of the circuits by connecting to the N4 and to the ground. And so in this case, I could check the output voltage and see its behaviors. So then this operation here is an interface that work like a dictionary. So then I plot I have all I could generate a post and zero as what we did in the part 3, and we actually have the same operation. Then for the next one, in order to plot the location of the post and location of a zero, I actually have the same operational Python code here, which is the same as to part 3. So all this part here is to generate the post and zero and plot the location of them. And then for the next part, it was decided to plot the AC analysis and see how the plot displaying the function of the circuits. So in this case, so C is the same as the 3 to the negative 10 to the negative 12. In order to calculate the equivalent inductor, so since the inductors L1 and L2 are parallels here, so the formula I use is the same as the resistors in parallel, which is equal to L1 times L2 over L1 plus L2. So I have the equivalent inductor is 1.67 to 10 of the negative 7. Then in 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 this case, I could also plot, and I have to add, since I had 3 posts in generate from the last code, from the last part of the code here. So I have to include all 3 posts in this operation, and 1 cell is included as well. So the K value and the H value in this case is the same as what we had in the same as what we have in the post-and-seal analysis. So the K value and H value are the same because we just observe different analysis, but the same components that we use in this circuits. So let's move to next. So this is a symbolic analysis. So actually at the beginning, before displaying the plot of the symbolic analysis, we plot the PC analysis first. Then we could generate a transfer function by using this formula here. The output over the input and then times the gain. So which is the formula we use to generate the transfer function. Then since I have to substitute the correct circuit value. In this case, with assigning all the components here, and since I have the capacitor equal to 3 to times 10 to the negative 12, and 10 ohms at resistor 2 and 20 ohm at the resistor 3. Then for the last part of the code is to plot the symbolic analysis with the PC analysis and AC analysis. Let's run the code here. Okay, so firstly, let's start from checking the post and seal. In this case, I have the cell like a times 10 to the negative 14 is so small, and which is very close to the origins, and another cell is equal to 1. So the plot of the singularities it matches the output of the post and seal, and I have the same values at the x-axis, which is a negative 3.44. The difference is on y-axis, which is negative 2.2 and a positive 2.2. So then we move on to the symbolic simulation result. And I have a different transfer function here, and I also list in the documentation, which includes I have the formula to obtain the current flowing fluid L1, L2, and the current flowing fluid voltage 1. So the transfer function is shown in here. Symbolic transfer function results for the RLC band pass. So the gain, the transfer function actually is equal to the gain, which is the output of the circuit divided by the input of the circuit. So they are also, so all the results should match what we have above here for the current. So in the first case, I have the transfer function for the current flowing through the inductor over the input. So which is the transfer function here. The post we could find by using this formula is so complicated, so I can't explain. And then for the second transfer function for the current flowing through the second inductor over the input voltage. So the second transfer function is shown here, and the post we could also like calculate by using this formula, and the cell is 0 in this case, and the cell is 0 in the first case too. For the third case, for the current flowing through the voltage source, and I have the transfer function shown as this, and I could also find the post by using these two formulas, and the cell is also cell for the four transfer function, which is 1, is so unbelievable. And for others transfer function like the voltage and node 2 over input, so I have the transfer function like here, and the gain cell, and I also could find the post by using these formulas. In this case, cell is not equal to 0, so it is equal to negative R2 minus R3 over C1 times R2 times R3, which is, as we could see here. So the C1 is a negative 3 point something to times 10 to the negative 14. And yep, and it shows all the transfer functions in as the output of different components and the currents flowing through each components. And we could see the AC analysis here, which is pretty generate from the code shown here, AC analysis. And we also have post and cell analysis like this, from negative 50 to almost to 0, and which is generate from the PC analysis program. And last, we have combinations analysis, including AC and a PC analysis. So the light blue shows the symbolic analysis, and we have a frequency equal to 107.297. So actually, the programs for all parts for all parts are great, and the last part is to pick one analysis to run the program to run on Spice. So as I show, so this is the part 1 operating point simulations to run the circuits and double check if the outputs are the same, and document the results and compare and provide your reason why they are the same or different. And I have the documentation paper in the folders too, showing which part is important and which part is the function of each part of the code. And I also include a README file for the users to understand easily how to run the Python programs in this folder. And that's it. I see you in lectures, and thank you.